But now on Radio 4, Adam Rutherford continues his exploration of the genetics of intelligence. Born smart, born equal, born different. Today he finds out what recent breakthroughs in genetics could mean for education.
At the dawn of the 21st century, there was fantastic optimism and enthusiasm about what the human genome might reveal. A feeling that our DNA could and would cure disease and provide answers to every question about what makes us human.
Today we are learning the language in which God created life. We are gaining ever more awe for the complexity, the beauty, the wonder of God's most divine and sacred gift.
The hunt was on for genes, for everything, and intelligence was no exception.
America's founding fathers declared that all its men and women were created equal. But now new research here is challenging that comfortable view. A DNA analysis of the blood of some of America's brightest children has shown that there's a genetic basis to their high IQ.
BBC News in the year 2000. Well, our genomes turned out to be almost inscrutably complex. Nevertheless, we can now read our genome with ease. We can decipher the 3 billion letters of DNA code that defines our biological inheritance. The cost of having your genome read is fast approaching the price of a Manchester United season ticket. And Francis Collins, the scientist who led the grand project of the human genome, believes that getting your genome done will soon be, well, just part of growing up.
Francis Collins does in the next few years, all children will be whole genome sequenced. All 3 billion base pairs of DNA will be sequenced in a little chip, it'll fit on a memory stick easily.
Well, he may be right, but I don't think that genome will be very useful to them. I think actually that has been overstated. When Clinton first announced the first sequencing of the human genome, he said this is a God-given map more important than any map that's previously been written by humans. I think that we scientists need to stand back a bit. It is useful. It will become more useful. But I think we shouldn't be seduced by our own cleverness.
Today, in the final part of this series, I'll be bringing us right up to the bleeding edge of the genetics of intelligence. We've been studying DNA and cleverness for over a century, and we now know more about both than ever. We'll look back at how research in this area was used in the past, with questionable success, and forward to how it might be used in the future. And we'll be asking this question. Does our newfound understanding, particularly of our DNA, provide us with a roadmap on which we can base education? We are rapidly entering a world where the once cryptic information held in our genes will be available to everyone. And Professor Robert Plomin believes this new genetic knowledge could, and possibly should, be used to inform education policy.
These are data that could be used or misused, but there are reasons to be optimistic and positive about wanting to do good things with those data, and especially if Francis Collins is right and those data are just there.
My anxiety stems from the fact that there are dozens of companies out there already who will take a cheek swab from a kid and will give you a report back which says that they're going to be better at baseball than at American football. My anxiety is that in 5 years' time, we'll be in exactly the same position, but instead of high jump versus long jump, it's going to be maths versus engineering, or just bright kids versus not bright kids.
Well, it won't be 5 years from now. It's happening now. There's a lot of companies just lurking. Those companies take every report of a gene that's associated with anything because they know parents will buy them, so we have to watch that. But for the good science of it, if we had a few hundred genes that explain, say, 5% of the normal distribution, the variance between people in intelligence, I'd be concerned about predicting children who are going to have trouble learning. And that's within a family. That's the neat thing about DNA prediction.
Neat or scary, depending on your point of view. New possibilities maybe, but it also opens up a whole Pandora's box of concerns. Professor of Education, Michael Rice.
It's about the most powerful label one could imagine. If one really as a parent, or indeed as a child, is told that one has genes for lower intelligence, it's going to take an awful lot to try and overcome that, or even to try and understand that that's not an upper limit. And that is another reason why we would have to be very cautious about ever using genetics in education.
As the Human Genome Project was revving up, a science fiction film, Gattaca, made in 1997 and still shown in classrooms today, warned of the dangers of believing we were defined by our genes alone. The hero, Vincent, has been deemed genetically invalid and is trapped by his own DNA.
My father was right. My real resume was in my cells. Why should anybody invest all that money to train me when there are 1,000 other applicants with a far cleaner profile? Of course, it's illegal to discriminate. Genoism, it's called. But no one takes the law seriously.
I mean, before I went in, I saw the previews and thought, this is just another movie where they're just going to say science is wrong and science is bad.
David Kirby, geneticist turned historian and Gattaca expert.
And when I watched it, I thought it did a great job of identifying the problem isn't so much with the technology, it's how we think about the technology or how we think about science and the ways in which DNA and genetics, might inform who it is that we are. How might my genes define me, and what happens if we think our genes define us as well?
Good science fiction shines a light on our contemporary fears. But what about the real world? Could our knowledge of the genome one day be used to screen for intelligence? Are we right to fear streaming at birth? Professor of Genetics Steve Jones.
I think we're in great danger of being bewitched by technology. Genetics has clearly been going backwards at some speed since the human genome was first sequenced a decade or so ago.
And Professor Lord Robert Winston agrees.
The one area of the genome sequencing which has been useful has been with the single gene defects, Duchenne muscular dystrophy, cystic fibrosis. And the problem really, of course, is that we don't die of cystic fibrosis. We die of heart disease, we die of diabetes, we die of renal failure, we die of cancer. Those are the things which kill us. And the trouble is the genetics there are really complex. They're not single gene defects.
And if that's true for diseases such as cancer, what hope do we have for understanding the genetics of the most inscrutable aspect of the human condition, our intelligence?
Well, it's very clear that intelligence is certainly not due to a single gene or even a few genes. It's obviously a whole range of different things in our genome. Also, of course, how those genes actually function, which may not be the actual printing of the genes, but actually how they work.
So intelligence is a polygenic trait. There are many different genes that can influence it. But beyond that, it's not just that there are many different genes, but also that there's an environmental effect, that genes may have different effects, both depending on the environment in which someone is brought up, but also on the genetic background overall.
Bioethicist Dr. Sarah Chan. So, there are many genes, each of which has a tiny influence. And they interact with the environment, which, as we heard in part 2 of this series, covers not just the comforts of our upbringing, but everything that is not genetic, starting from the moment of conception. In short, Bill Clinton's dream of the genome answering humankind's questions was not to be realised. Geneticists knew that, but the hype was overwhelming.
There's always going to be scientists who say genes can do more than they can. But I think when you talk to most young geneticists, they understand that the interactions between genes, environment, society, that's what makes you who you are.
Or in the cheesy but effective tagline from the film Gattaca, there is no gene for the human spirit. Gattaca was released in 1997, and it tapped into many of our concerns before the human genome was even finished. The dystopian, eugenic future it predicts has a basis in reality. We are right to care about intelligence because its impact is far greater than on your ability just to do crosswords. Moral philosopher Peter Singer.
Intelligence clearly has a role in determining our life prospects, our life chances. A fairly general thing, and of course we can argue about exactly what it is, but the things that IQ tests measure, generally speaking, have a role in determining what kind of income we will have and what sort of social class we'll belong to and perhaps how much power we will wield. So these things matter. We like to think that these things are within our control, but if intelligence has a significant genetic component to it, then they're not fully in our control. And that troubles us. The idea of, if you like, someone being predestined to have a lowly, not so well paid, low status position in life is something that we do find troubling, and in a way we should find troubling.
It's not a happy thought that some people will be better off in life because they won the genetic intelligence lottery. In the decades following the Second World War, there was considerable resistance to scientists who studied this field for precisely this reason. At the turn of the previous century, however, Francis Galton, the first man to study the inheritance of intelligence, fantasized about a world in which people were tested for their physical and mental abilities, and their fate was decided accordingly. Cultural historian Matthew Sweet.
He was working in his last years on a novel called Can't Say Where, which is a picture of a eugenic England of the future. What you get is a portrait of a society in which people take exams and are tested before they're given the privilege of having children. And people go into this great hall, and if they pass the test, then they're allowed to reproduce. And if they don't pass it, then they go off and work in a labour camp somewhere far, far away. But this isn't presented as a particularly negative idea. This is a novel with some ambivalence in it, but it's absolutely not a picture of a nightmare future. I think when you read this work, which wasn't published in Galton's lifetime, you are seeing the future as I think he would have wanted it.
In Galton's day, testing mental ability to sort children was a science fiction fantasy. A few decades later, it was reality. Psychologist Cyril Burt introduced intelligence tests in the UK to identify naturally bright children who might be disadvantaged in other ways. Yes, we have a scientist to thank for the 11+, introduced in 1944. Cyril Burt met Galton when he was a boy. Galton gave him a signed copy of his book, Hereditary Genius, which Burt treasured. They both believed that a large part of our intelligence was inherited, and that testing people was a good way to ensure that those with good genes thrived. Galton, with his not inconsiderable ego, assumes that upper-class gentlefolk were generally blessed with more of the bright stuff. That wasn't Cyril Burt's motivation.
Cyril Burt could see his studies as opening up equality of opportunity for those bright people whose parents were not gentlemen, if you like, from working class backgrounds, who could then have the same opportunities. And that could be seen as a very good thing.
It is true, of course, that he's completely fallen out of favour, because we now know from meticulous research in the 1970s that he did fake quite a lot of his data. These are data to do with twins separated at birth, where you then follow them. Actually, to be fair to Cyril Burt, the data that he faked was simply reinforcing what we already knew. So it's important to emphasise that even if you discount all of his faked research, you don't change any of the underlying conclusions.
Like Galton, Cyril Burt is a troublesome figure in this story. After his death in 1971, there were widespread accusations of faking data and even inventing colleagues. Nevertheless, he was the first scientist in the UK to advise government on education. His research was the basis for the 11+. Studies of intelligence were no longer just of academic interest. They were being used to reform society.
There was, from about the 1910s right through to the 1950s, a pretty naive belief that we could use the results of these new studies to characterise students and separate them into different groups, and indeed, of course, provide completely different schools.
The Butler Education Act of 1944 introduced 3 different types of schools: technical colleges, secondary moderns, and for those who passed the 11+, grammar schools. Children were now being sorted according to ability. Steve Jones.
It was particularly, I have to say, painful for my family, because I passed the 11+, and I was well taught, I got to university, and I'm extremely grateful for all that. My brother failed the 11+, and I can tell you he was shattered by that. He went to a secondary modern school that was basically useless. He learned to lay bricks, and he was a good bricklayer. Now, of course, he's too old to lay bricks. You often hear people say, bring back the grammar schools. You never hear people say, bring back the secondary moderns.
The introduction of the 11+ was always controversial. Have a listen to this edition of Question Time from 1968.
Does the team feel that the common use of the words pass and fail when talking of a child's attainment in the 11+ selection procedure is totally misleading? Shirley Williams, know about this?
I don't know that I know about it, but I think it's not only misleading, I think it's positively wicked. I would say that the phrases pass and fail should apply only to somebody at the end of their life, and it should be a judgment of their whole life, and it should be based on character and not just on how many electrodes they've got in their heads.
Question time in 1968, same as it ever was. At least part of the problem with the 11 Plus, I think, was that an ability to pass or fail within a single exam became shorthand for judging people's worth. It also raised the question of what education is for. Surely at least part of its purpose is to maximise intellectual potential. But what are we actually talking about here? Intelligence is such a fuzzy concept. There are at least 8 competing definitions. The measure everyone knows is IQ, which tests for aspects of intelligence: reason, linguistic dexterity, logic. But there are other forms, such as spatial awareness, musical and interpersonal skills. They all make the essence of intelligence notoriously hard to bottle. Sarah Chan.
We risk, I think, reinforcing perhaps a too narrow view of what intelligence is. And if intelligence is a proxy for people having opportunities in life, for people's ability to pursue a better life, to create a better society overall, then I think just measuring what we might call and test as intelligence these days is perhaps far too narrow a characteristic to be looking at.
And yet, when we say that person is really clever, we do sort of know what we mean. And it was this rather nebulous idea of intelligence that Galton and statistician Charles Spearman wanted to measure.
I think the big advance came with the notion that there was some general concept, some general property in the human mind which predicted many human attributes. And Spearman had a thing which he called G, Spearman's G, for general intelligence. Now, G doesn't have much explicatory power in its own right, but it's based on a variety of things. It's based on verbal puzzles, on the ability to manipulate shapes, on the ability to do simple sums, all these things. And it's clear that these abilities tend to be correlated together. If you're very good at doing sums, you're probably quite good at doing verbal puzzles. So he suggested, and I think in some ways he may well be right, that there is some general property within the brain which predicts the ability to do many, many different tasks. He called that G.
Kids who are good at maths and English and history and languages, well, they probably score a high G. It's a measure that reflects the statistical probability that success in one subject goes hand in hand with success in others. IQ tests come in all shapes and sizes, and they've been refined over time. But the basic idea is the same, an attempt to measure some underlying ability, a way to get to G, general intelligence. Robert Plomin.
I think it's the best measured trait we have in the behavioral sciences.
Well, why is that?
Because we know it's difficult. And you know that you're trying to get a composite across a lot of diverse things. So you have to be concerned about the reliability of it, the validity of it. So it doesn't matter what you measure. As long as you measure diverse cognitive tests, you're abstracting what they have in common.
If you understand it as the ability to do IQ tests of the kind that get set, then, well, that's fine, I suppose. It's rather limited.
Professor of Statistics, David Spiegelhalter.
But the point is that it's not measuring, I don't believe it's measuring some absolute characteristic of yourself. It's fine if it's just considered as an ability to do those particular type of tests. But it's so quick that these things can suddenly be thought of as absolute measures, and then you start finding policy decisions being made on the basis of these things, people being classified as one thing or another. Very dangerous.
Which, of course, is precisely what happened with the 11 Plus. Yes, our measures of intelligence are far from perfect, but we have been refining them for a century now, and they do tell us something. Now, I am a geneticist, not an education expert. The genetics of disease informs medicine and health policy, and with the 11 Plus, the genetics of intelligence influence schooling opportunities that defined children's lives. But isn't it odd how willing we are to accept inborn health inequalities, and how squeamish we feel about inborn differences in intelligence? Peter Singer believes we should be open about genetic differences in intelligence, just as we are with health.
It is a terrible form of inequality that some people are likely to die in their 40s and other people are likely to die in their 80s. We do say, well, yes, some people have genetic misfortune, but we're going to do what we can to make sure that they still get the same care as everyone else. So even if somebody is born with a genetic disease, that means that over their lifetime they might need, let's say, £5 million worth of healthcare expenditure. We're going to give it to them. And that might be paid for by taxpayers who over their lifetime are going to need healthcare expenditure that is perhaps 1,000th of what this other person is going to have. And in a way, I'd like to say something similar about the costs of differences in intelligence. That is, that we should also try to provide assistance for those who are not doing as well because of their lower intelligence.
Our 21st century insights into DNA are now being used to improve our health. Could they also be used to identify children who are at risk not of disease, but of lower than average intelligence? Professor of Education, Michael Rice.
All children now at birth almost automatically are tested for a number of conditions, some of which are heritable. And the reason for that is just that the earlier you know about these conditions, the easier it is to do something about it. It's therefore possible that genetic diagnoses one day might play a role in education comparable to the role it's already playing in medicine.
Michael Rice says it's possible. Robert Plomin also believes our DNA holds extremely valuable information that could help children learn.
We really do need to recognize that genetics is one of the big reasons why children differ in how easily they learn. And I think we need to recognize those differences and respect them.
So if we could predict a level of intellectual capability at toddlerhood based on DNA, what would be the practical implications of that? What would you actually do with that information?
Well, I think it will be increasingly possible as whole genome sequence data are available for all children. And we can use that DNA readout of the 3 billion base pairs of DNA to take even hundreds of genes that predict some sort of learning disability, for example, like reading disability, or more general learning problems, or more specific learning problems. We could get different sets of genes to predict these different sorts of problems. We could also, and this is really looking towards the future, begin to find environments that interact with those genetic propensities. So it made this type of environment, this type of intervention, for example, works particularly well with children who have that kind of specific genetic problem versus the others. And you might be able to do some of this stuff without genetics, but genetics just brings it to a much more sophisticated, we hope, effective level of intervention.
Well, I think it's way too early to know what such an intervention might be. Thousands of genes are involved in brain development, and hundreds of them have been shown to have only a tiny effect on intelligence. I believe that we are years, possibly decades, away from being able to make such a diagnosis. We can, I think, draw useful comparisons between the genetics of complex disease and intelligence. But let's not over-egg it. Robert Winston.
The need to pursue the genetics of disease is obvious because it will lead undoubtedly to increasing advances in medical practice, though I think they will take much longer than we actually predict. The need to deal with the genetics of intelligence is much less clear-cut.
Which brings us to the nub of the problem. What value is knowledge of genetics to education? This was never going to be something that we all agree on. There's just too much at stake. But I hope at least we've overcome some of the squeamishness of even discussing it. Squeamishness that has dogged, polarised and paralysed the debate about intelligence for the best part of 50 years. The crux of the matter now in the 21st century is this. Is genetics going to help teachers teach?
I think teachers ought to be knowledgeable about this information because one thing that interests me a lot is overachievement and underachievement. And what people mean by that is underachievement given the level of ability you have. So the genetics can predict not only that ability, but the discrepancy between ability and achievement. And that would be interesting for a teacher to know. This child is really underachieving, but their genetic propensity suggests they ought to perform better.
But this is the key problem. People like us with backgrounds in genetics have spent most of our lives thinking about the key aspect of genetics, which is that it's probabilistic. It's not deterministic. And when you start talking about that to people who don't have backgrounds in genetics, they just assume that genes are destiny.
Yes.
Right? And that's a big, big problem.
It really is. It's the fundamental misunderstanding about genetics. And there's so many examples, though. I mean, you take obesity, it could be 100% heritable. It isn't, but suppose it were. It doesn't mean you can't lose weight if you stop eating. It's just saying of the differences that exist in our society at a particular point in time, genetic differences, DNA differences between people substantially account for some of those differences we observe.
So let me ask you this question then. Are we ready as a society, as a government, and as a culture for the type of information that you are providing us with?
I've been really struck with this latest round of controversy. It comes up with me every 5-10 years or so, and I've had 40 of these years to experience it. And it's been amazing to me how much more receptive people are. Everybody is, even education, which is the last bastion sort of anti-genetics thinking, in my view. And so I'm an optimist, and I hope things will work out.
But Robert Plomin's optimism about the future value of genetics for education is not shared by Sarah Chan. For her, genetics is the wrong emphasis.
Even in a fairly far-off future where we understand many of the genetic determinants of intelligence far more than we do, I think it is still likely to be economic and social inequity that has far more effect on people's performance, people's ability to fulfill their potential and the opportunities that people have than their genes. So while there may be some element in a far-off future educational policy for perhaps teaching people in a way that they're most suited to learn because of their genes, if we don't address the far broader factors of environment, we're not going to achieve the kind of advances we want to make.
But in the context of that, it surely has to be very important to acknowledge that we aren't all born equal. We have to acknowledge that some children have different abilities from others.
To say that we are all born different is not to say that we're not all born equal. And that, I think, is where a lot of the fear lies with this form of research, that differences, be they innate, inborn, or environmentally induced, differences between people are going to be used to judge the worth of people.
That's where the fear stems from. We are not born equal in the intelligence stakes, and we worry that this knowledge might be used to promote or condemn. We began this series with headlines that declared genetics trumped teaching, ideas that nurture a deep fear about social mobility, about streaming in education. These anxieties have their roots in the troublesome history of this subject. But I believe that the only way through the minefield that is the inheritance of intelligence is to face reality. We need to embrace the notion that when it comes to intelligence, however you want to define it, some people are born smarter than others. This is not a value judgment. By acknowledging this fact, we could find ways of using it, not to create a more unequal society, as is the fear, but to allow all children to fulfill their potential. We are not born equal. We are simply born different.
Intelligence, Born Smart, Born Equal, Born Different was presented by Adam Rutherford. The producer was Anna Buckley.